Section 1.2, example 6. Write an equation from looking at a graph. They give you a word problem here. We're on a scenic train ride going along an old mining line. The graph is showing us our distance in kilometers of the train from the station X minutes after the ride begins. What equation would represent the distance from the station as a function of time? Okay, so y is a function of x. Time is in control. We want to see how y is changing compared to x. When you look at this function, what do you think of? Parabola, line, or absolute value? If you said absolute value, you are correct. Absolute value of x is the parent function. However, if it was simply the absolute value of x, it would be here at 0, 0. And it would be climbing at a rate of 1 to 1. We would still get up to this point like 15, 15, but it would be centered on the origin and right side up. So apparently this graph has been flipped upside down, shifted right, shifted up. So we need to come up with a good equation for this. Let's see, so if we wanted to move this thing right, up, and make sure that it flips, you would actually do it in this order. You would tell it to flip first, flip down, so it would look like that. Then it would shift right 15 and up 15. I think that's what we need to do. So how would we take an absolute value and flip it upside down? I think we're going to stick a negative right there. How would we shift it right 15? Minus 15 on the inside, up 15, plus 15 on the outside. All right, so the domain goes from, looks like if we take these arrows off, goes from 0 to 30. Okay, the domain would be 0 to 30 for x. We start at 0 minutes, we go for 30 minutes. Looks like after 15 minutes, you're 15 kilometers away. And I guess that's about it. That's all they were really asking us to do in this example. If you want to try graphing that on your calculator, go for it. Make sure we did it right, but I feel pretty confident in it. Let's see what's going on here with your try it problem. It says, how would the graphing equation be affected if the train traveled twice as far in the same amount of time? Okay, twice as far in the same amount of time. So I want you to think about how this slope would change if you're going twice as far. This distance would not be 15 kilometers away, it would be 30. All right, so I want you to think about what this graph might do, what equation might make it get there. So that's the try it for you to complete. We'll talk about it in class tomorrow.